session, while creating the workspace, we had seen different types of license modes like Pro Trial, PPU, that is Premium Per User, correct? Premium Capacity, Fabric Trial, and Embedded Capacity. Now, the Pro Trial does not exist because that has been taken over by the PPU trial now. But in that, let's understand the concept of what the license is associated with. So in case of a Pro license, the license is assigned at a user level. Similar is the case that was with respect to the Pro trial. Premium per user, as the name suggests, it is per user. So the license is at a user level. Then comes premium capacity, what is called as PSKU, that is premium SKUs. Now in that, and capacity is bought. When I say capacity can be considered as the engine on which your Fabric or Power BI others are getting executed. To execute something, you do need some engine or some power, correct? That is what one can consider as the capacity. So you are buying a dedicated capacity for yourself, and that capacity, one workspace can be associated with only one capacity, but one capacity can be integrated in multiple workspaces. Then there is Fabric capacity, which is called as FSKU. It's also at a capacity level. Now Fabric trial, when I say it is tenant wide, if you all remember, I had said that recently due to that gross misuse, they have added a tenant aspect, correct? So there are some fixed set of free Fabric trial licenses that are granted at a tenant level by the organizer, by Microsoft. And then it is associated from tenant, it gets associated to individual user level. That's what we had seen via the admin center. Then there is embedded capacity, which is called as ASKU. That is also at a dedicated capacity. Hence, in case if you all see here, for the first three, there is no dedicated capacity because it is at a user level. Whereas others, we are preserving a dedicated capacity. Then support free users as viewers. What does that mean? Imagine that the workspace that is created with the corresponding license, meaning these are the license modes associated with the workspace, correct? So imagine that in case if I have a workspace of type Pro and I publish a report, then the users who want to access that report must also have a license, a minimum license. It does not support free users to view to view the reports. Since the license are at an individual user type, hence the reports associated in that workspace must also be for the users who have licenses. Whereas since these are dedicated capacities, the users need not have license because I have got a dedicated capacity. So it's my personal home. It's up to me to allow whoever I want to within my home. Correct. Hence, there is no need for individual users to have a license in order to access the reports within these workspaces. Then there are some advanced features and functionalities like refresh frequency. Now in Power BI, there are two modes of data. One is Connect Live, wherein your report Connect Live or direct query. This we'll see in detail in the end sessions, but for layman terminology, your report is directly connected to the source. Whenever a user is trying to access the report, indirectly that user is accessing the data at the source at the runtime. That is what we call a direct query or Connect Live. But then there is an import mode wherein at some scheduled intervals, you would be importing the data that is present in the source into the Power BI cloud service. and your report would be built on the data that is present here rather than every time hitting the source. Hence, you need to there would be a scheduled frequency at which you want to import that data. That is what we call as import mode. And there are certain restrictions wherein in case of Pro and Pro trial, there is maximum of 8 refresh that you can do per day. Whereas for other capacities, it is 48 times per day. And as I said, when you are importing the data is being physically preserved in the Power BI cloud service itself. Hence, in case of Pro and Pro trial, the maximum, it cannot go beyond 1 GB. But for other capacities, there can be data sets which are greater than 1 GB. When I say data sets, is the semantic model, the report. The underlying report holds some data. Since you are importing that data from the source into the Power BI service, so the data that is present cannot exceed 1 GB in case of Pro and Pro trial. So these are the different features and functionalities that are associated with the license mode. Now, Pro trial is no longer present because Fabric trial or the PPU trial, which is a higher license mode, is supported. So automatically, Microsoft provides the best benefit in case of trial. Also, eventually, PPU capacities are getting deprecated. And Microsoft is asking the users to move away from the PPU capacity. Sorry, not PPU. The premium capacities are getting deprecated, and Microsoft is eventually asking users to move away from the P capacity to the F capacity. So any queries before we proceed on to the data basics?
This thing that you mentioned about suppose free users and viewers. So when it in the Pro it says no, that means we cannot use the report also. You can.
Sorry, Shweta, your voice is not clear.
Okay, is it better now?
Somewhat, yes.
Okay, just give me 1 minute, huh? Okay, I'll take it and play. Yeah, you said. I'll just take one quick and discuss it.
So by the time we get back, now yesterday we were covering the basic categorization of data. Data can be structured, semi-structured, or unstructured data, or the files, to be more specific, can be of 3 types: structured, semi-structured, or unstructured. Now, in case of structured data, the data is properly in the form of a tabular format, in the form of proper dedicated rows and columns. In case of unstructured data, there is no proper structure defined, like images, videos, audio files, etc. In case of semi-structured data, there is an ability to parse the data meaning by just visualizing it, we will be able to parse the data, but it is not aligned in a proper structural format. It can have varying structure depending on entity to entity and row to row. That is what we call a semi-structured data. Now, the examples of semi-structured data is like the JSON file or the XML file. Now, since the basics are clear, let's focus on yesterday's query. Whether, I hope most of you all know what an array is. Array is a collection of objects which can be of similar or different data types. I used another terminology called data type. Now, there are multiple categorization of data based on how the data is being preserved. Like in case the data is true or false, or like 1 and 0, we call it as a Boolean data type. If it is numerical values, then there are multiple categorization of numerical values. If it is whole number like 1, 2, 3, then we classify it as integer data type. Now data types change depending upon which coding language you all use. In SQL, and that too in SQL also there are different types of SQL. SQL stands for structured query language. Now to query the structured data, there is a language called SQL, structured query language. Now depending upon the engine on which you are executing the query, the SQL syntax changes. Like in Microsoft ecosystem, it is what we call as T-SQL, transactional SQL. But then there are some other databases like MySQL database or PostgreSQL database. So for those, there are accordingly PG-SQL, that is PostgreSQL, or MySQL. But the underlying basic keywords remains the same. It's just that some of the syntactical aspect and some more keywords are present here and there. Now, other than SQL, there are some other languages as well, like Python, Scala, Java. So depending upon the language, there are different types of data classifications. In certain cases, like the text values that we have, there are data types like text or string. Whereas in SQL, there would be data types like varchar, etc. So I won't be covering those in detail. Correct? Those I expect, those are the prerequisite with the common SQL understanding. But there was a question with respect to array. So now in an array, there can be nested array as well. And within the nested array, depending upon the entity to entity or the index to index, the number of values can change. So there is no fixed defined structure, but you're still able to parse the data. Correct? So the data that does not have a fixed structure, but you are still able to parse the data based on some logic, that is semi-structured data. So array falls under semi-structured data. So now we identified different types of data. Now, today we would be focusing on categorization of files. Now, files are majorly classified into two categories. One we call as a row format and another is what we call as a columnar format. Now, what do I mean by row format and column format? These are the two major categories. Now, if you see, in case of row format, the data is present in the form of rows. That is, John has a value of 4.1. John is a student with roll number or ID 1 and he has a credit of 4.1. Similarly, this is the second row. So in case of row format files, the data is preserved in the form of rows. Now the best example for the row format is our Excel file or the CSV file. Now in case of column format, the data is transposed, meaning the data is preserved in the form of columns. So all the columns are clubbed together. So column 1 that was present here is transposed, is now part of a row. So 1, 2, 3, John, Mike, Sally. Now, what is the benefit of the row format file and the column format file? And how exactly and what exactly does the engine in the backend do? So let's deep dive into that. So now, in the traditional and row-based format or the row-based storage is a traditional storage aspect. That's the first initial aspect, correct? So in the traditional row-based storage, the data is stored in the sequence as a sequence of rows. So here you can see that these are the different attributes, that is columns, product, customer, country, date, and sales amount. And the data is preserved in the form of rows. So this states that the row 1 states that I have a product ball that was bought by the customer John in country USA on 1st of January 23 by 100 rupees. Now, imagine that if I have a requirement wherein I get a question that how many users from USA have bought a t-shirt, or what is the total amount spent by customer Maria Adams. So these are the analytical aspect. So in the traditional data ecosystem, data systems are classified into two formats. One is what we call as OLTP, that is transactional protocol, and OLAP, analytical protocol. So there are two categorization of data storage systems. OLTP, that is transactional systems, OLAP, which is analytical system. Now, when I say transactional system, can anyone guess in your normal day in, day out aspect, what does transaction mean?
Any transaction, bank transaction you can consider, right? Sales and
Correct.
orders, whatever, right?
Correct. So any simple transactions that are happening, correct, at the moment aspect, meaning let's imagine that you have an Amazon app. In Amazon app, you add something you want to do shopping. You add in the cart. So that's the transaction that is currently happening. So preserving the recent aspect is what we call as transactional systems. But imagine that in that storage itself, if I now in Amazon, you will see that previously you had bought this, or people who buy this usually buy this along with that. Now, on what basis is Amazon or such Zomato or such apps suggesting you? It's based on the historical transactions, historical data that they are analyzing and providing some suggestions. So there are some analysis that are going on based on the historical data. Those are called as analytical systems. So imagine that if your data is preserved in the form of rows and I want to do analytical aspect with respect to the total amount that has been spent by the customer Maria, or how many users from USA have bought the t-shirt. So in that case, what I have to do is I have to scan across each row and every column in this case, because to move to the next row, I have to first scan across all columns. So even though in this case, that is the total amount spent by the customer, I just need customer and the sales amount column. But in this case, I have to parse across every row. Now every row, because I do not know which customer, I have to identify the customer initially. So first I'll start with this row. Okay. In this row, I see John Doe. Hence, I need to skip this row now. But to move to this row, I have to first parse across the entire columns. So I'll first start from row 1, column 1, scan, then move to row 2, column 1, scan, row 3, column 1, row 4, and similarly. So to be able to answer any of these analytical questions, the engine has to scan each and every row from the beginning till the very end. And essentially, I just need the information from these two columns. In case of the first query, it is the products and the country. And in case of the second query, it's just the customer and the sales amount. But in the traditional row-based file format, I am forced to scan each row and all the columns. So is this a performant efficient way in today's data-driven world? No, correct. So for that, there is another file format called column-based file format. Now in column-based file format, each column is physically separated from other columns. So if you see now, each column is physically separated from the other columns. Now product, customer, country, date, and sales amount. So the columns are separated from one another, unlike the earlier scenario wherein the columns are bounded together. Now, for the same question, that is, how much amount did Maria Adams spend overall? So in this scenario, the engine can now skip, since I already know, correct, the customer, I need the customer and the sales amount column. So in this case, the engine can now skip other columns that are not needed by the query, thereby skipping the scanning of the unnecessary columns and improving the performance of the analytical queries. Here also it has to scan across every row, correct? Because in customer column also, I have to scan every row where Maria Adams is present. So, irrespective of the file format, that is the column-based file format or the row-based file format, I have to scan across each and every row. But the benefit is, since the columns are physically separated, I can skip the columns that are not needed for my analytical queries. Since I'm skipping those, automatically my performance would increase. So this is the benefit of column-based file format over row-based file format. Any queries up till now?
So, Nandan, it's not like a file input, right? It's like the Fabric is storing the data in column-based file format, and
We have
so.
yet not come to Fabric, Krishna.
Acha,
We are yet
okay,
understanding
acha.
different file formats in the data world. We have yet not come into Microsoft Fabric or
Okay.
anything.
Oh, okay. Got it.
Clear?
No, yeah.
These are different file formats that exist today, irrespective of Fabric. Any queries up till now? If no, then there are some. Then now let's compare the difference between these two. Now, in case of row-based file format, the storages, the rows are together. Whereas in case of column-based, the columns are together. Meaning it's in the columnar format, which are physically separated. Now, row-based, and remember, it's not just row-based file format, but it is majorly with respect to data world also. In SQL also, you would hear call indexing, columnar or row, correct? So the overall concept remains the same, meaning how the data is being preserved in the backend. So the use case is OLTP, that is transactional aspect. Imagine that the transactional is I added something in the cart. So I need that entire row for myself. So in that case, I want a quick retrieval of that entire row. So in case of transactional aspect, wherein you want a quick retrieval or a fast retrieval of the rows, that's when you have the benefit of row-based aspects. Whereas in case of analytical aspect, you are not concerned with the rows. You are concerned with the aggregation at an attribute level. What that is, what is the overall revenue that my organization generated in last quarter. So it's basically an aggregation at a column value. So it's column retrieval. So for fast column scans or the analytical platforms, you use column-based aspects. So the speed for row access, definitely row-based file format is quicker and column-based file format is slower. And in case of speed, for columnar access, row-based is slower and column-based is faster. Now, row-based file format provide a poorer compression aspect, unlike column-based file formats. And we'll not deep dive into why that is the case. And certain examples of the row-based file formats are CSV, Excel, JSON, or Avro. Whereas the column-based file formats are Parquet and ORC. Now, let's deep dive into one of the file format, that is Parquet file format. Now, why am I concerned with the Parquet file format? Because in Microsoft Fabric, the data is being preserved in somewhat similar format itself. So now let's deep dive into the Parquet format. Now, Parquet format is a columnar format itself that stores the data in row groups. So if you see, isn't this similar to the columnar format itself, wherein the columns are physically separated? So Parquet is an advanced form of columnar format wherein your rows are clubbed together. Rows are grouped. So the data is stored in the form of row groups. So now what is the benefit of this? Can anyone guess what would be the benefit of having the data in the form of row groups? No thoughts? See, if you remember, let's try to imagine the benefits, correct? In terms of
Scanning, right? Nandan, scanning time would be low run in case, right? It has to scan group 1 and group 2, group 3 only, irrespective of number of rows.
No, within the groups also it has to scan the individual rows itself, correct? So irrespective of whether I go into row group 1, I'll have to scan these 2 rows, correct? So let me go back to the ones. If you see in row-based file format, to answer any queries, I have to scan across every rows and every columns, correct? Meaning to just answer a simple question, I have to scan row by row across every columns. But in case of a columnar format, though I have to scan every row, I can skip the columns based on the necessary columns that are needed for the analytical query. So in case of that customer and the sales amount, I can skip this, thereby increasing the performance. But still, I have to scan every row. So now Parquet is a columnar format with an advanced concept of preserving the data in row groups. Now what happens is, let's take the question of Maria Adams. How much amount did the customer Maria Adams spend? Correct. So which column am I concerned with here? The customer column and the sales amount. Agree? So automatically I can skip product, country and the date column. Since it's a columnar format, I can specifically select the columns or scan the specific columns in itself. Any queries up till now? But now let's consider the customers. Correct. Now the data in Parquet is preserved in the form of row groups as well. So in which row group am I seeing Maria Adams? It's in row group 2 and row group 3. Correct. So in this case, I can skip the row group 1, thereby skipping the first 2 rows. And in that case, I'll not be scanning all the rows. I'll be scanning only these 2 row groups. So automatically my amount of scan time reduced across column and across rows. Hence, Parquet is a best file format that is commonly used in Delta Lake aspects in major big data world. Because in case of columnar aspect, it is automatically skipping the unnecessary columns. But unlike the traditional column format wherein it had to scan every rows, here I am skipping the row groups where I do not find that necessary data. Though here I have to scan this unnecessary row of Antonio Grant, but at least I am skipping the some rows based on the row groups. But then the question comes, how the hell did the engine come to know to skip row group 1 and only focus on row group 2 and row group 3? Any ideas? Any guess? Let's keep this interactive. You all can think, correct? What can be the cause or what can be the reason that the engine was able to understand to bypass this row group?
Means engine will search the Murray Adams first, right? Whatever it exists, right? That will scan the group only.
But again, you use the term search, correct? For me to search whether someone is here, I have to first enter this row, correct? It means you are scanning those. But I said that in case of the row groups, this row group 1 won't be scanned because this row group does not contain Maria Adams in any of the rows. So how was the engine able to identify without actually scanning that this row group does not contain Maria Adams? It is because in Parquet file, the data, the row groups are preserved as metadata. There are metadata involved. So corresponding to row group 1, it would have a metadata of distinct products, distinct customers, distinct country. So corresponding to every row group, there would be some metadata, the minimum and maximum value, the distinct values. So what happens is the engine first goes across the metadata of the row groups corresponding to the customer column. So it saw that in row group 1, the distinct value for the customer does not contain Maria Adams. Hence, it skipped this row group. So it only went to the row groups whose metadata in customer column has Maria Adams as the value. And similarly would be the case with, in case if I want to filter on USA country, correct? In case of USA country, since USA is present across all three rows, all three row groups, it would go across and scan everywhere. But in certain cases wherein there can be a benefit, it would skip those row groups. So in case of the traditional row based aspect, I had to scan every row and every column. In case of traditional column aspect, I had to scan every rows but specific columns. In case of Parquet, which is a columnar format preserving the data in row groups, I had to scan specific columns and specific rows. Hence, more in big data world, in today's aspect, most of the architectural or data world uses Parquet files as their sources because it is quick data retrieval aspect and it supports a very huge compression or a best compression aspect, unlike a traditional row based aspect which support poor compression. So with big data, I have to preserve a heavy set of data. So it's better to preserve the data in compressed format rather than flat format. Hence, we use Parquet format. So any queries up till now on the concept of what the Parquet file format is?
Any file format Nandan can like which only work on columnar scan only columns like Parquet scans row with row group, right?
Correct.
Yeah, so any file format that scan only column.
You're asking me which file? It's the ORC. ORC is a column-based file format only. Parquet is
Okay.
also a column-based file format,
Yeah.
but with some additional aggregation at
features.
row-based. Row-based and column-based are the two categories, main categories. So Parquet is a column-based file format only, but with some additional features of even grouping it based on the row groups. I hope that was your question, correct?
Yes.
Okay. So any questions before we proceed ahead? Now, unlike the traditional row-based file formats like Excel, CSV, or the JSON files, wherein you can open the file from your local system and analyze, column-based file formats like Parquet cannot be opened and analyzed. You need some tools or coding language to actually read those files. You cannot double-click that file and open and analyze the data because it's in compressed format and some other aspects. So you can read it based on Python or some coding languages. Any queries? If no, then we will proceed ahead. So now we understood what the Parquet file format is. Now let's come to Microsoft Fabric. In Microsoft Fabric, if you all remember, I had stated that Microsoft Fabric is a software as a service tool created by Microsoft that supports end-to-end analytics and data platform that is designed for enterprises that require a unified solution. It contains everything from data movement to data transformation to data storage, or what we call as databases. Now, in Microsoft Fabric, there are 4 types of databases today. There is something called as a lakehouse. There is something called as a warehouse, SQL database, and KQL database. Now, once we deep dive into what Microsoft Fabric is, at that time we would understand, we'll cover each and every database type. But for now, let's just understand that as of today, there are 4 database types. And a new database type is also coming. That was recently reviewed, called Cosmos database. That is a NoSQL database. Now, the SQL database and the KQL database preserve the data. The data is preserved in a proprietary storage format. Now, when I say proprietary storage format, it means we are not aware. It's the underlying vendor who knows how the data is being preserved. But in case of lakehouse and warehouse, the data, the underlying data that is being preserved is in the form of Delta Parquet format. Now, when I say Delta Parquet format, can anyone state whether it's of type Parquet file format itself? Any guesses?
Parquet file with transaction log.
Okay.
That is called a Delta Parquet.
Okay. A heavy terminology to use with this audience who are new to this aspect, correct? But you are absolutely correct. So basically, Delta Parquet is an advanced version of Parquet file. One can consider it as on a steroid version of Parquet, correct? Wherein, let me go to the Power BI workspace. So who all here are familiar with the concept of SQL Server or have worked on SQL Server? Can you all raise your hands? So in SQL Server, you all might have heard something called as LDF file and MDF files. Who all here have heard about MDF and LDF?
Yes, Nandan.
So MDF stands for Master Database File and LDF stands for Log Database File. Correct? Now the master database file contains your data, whereas the log database file contains the changes that have transpired with that data, meaning the different set of transactions that transpired across that data. Imagine that I have a table X that contains values 1, 2, 3, ABC. So 1, 2, 3, ABC is your master database file. Whereas first time I would have inserted 1, 2, 3. Then I would have inserted ABC. So these are two different transactions that are happening. Correct? So preserving those transactions like insert, update, delete, etc. These is the log database file. So now Delta Parquet file can be considered as a combination of the LDF and the MDF file, wherein the Parquet file that contains the data can be considered as the master database file, whereas the LDF file is equivalent to a file called Delta file. Now let's take a look with respect to what that Delta file is.
So Nandan, I have a question here. One. So MDF can we consider as a metadata or actual data?
Actual data.
Okay.
So the MDF file contains the actual data similar to the Parquet file, whereas the LDF file in SQL Server is the transactional data that contains logs, which is equivalent to the Delta data here, and that I'll show. So I am in a lakehouse. Let's forget what lakehouse is as of today. Correct? The main focus of today is to understand the file types and the underlying file structure in the Fabric ecosystem. Now, the initial load of the data does take some time because the engines are getting ready. So if you see, I have a table called test. Correct? And it is showing me 5 rows. 1, 2, 3, 4, 5. Now, if I click on the ellipsis here and click on view files, in the underlying, the data is being preserved in the form of Parquet files with some delta, with some logs. This is what we call as Delta Parquet, wherein the data is present in Parquet, whereas there are transactional aspects that are being preserved in the log files. So now let me click on the Parquet file here. If you see, this Parquet file contains only one row. This Parquet file contains another row, meaning the data is being preserved in the Parquet files. Whereas this latest Parquet file, let me sort it. This latest Parquet file contains all the 5 rows. And we'll understand how come the earlier files had individual rows, whereas this one file has all the rows. Correct? These are some of the advanced concepts that we would deep dive once we actually take a look with respect to what lakehouse is, what warehouse is, etc. But for today's understanding, the Parquet files are the one that contains your data. Whereas, let's go into the Delta log folder. If you see, there are different log files that are getting generated. Now let's take a look in the log files. This states that there was a write operation. I wrote something or I inserted something into the table. Write operation. Here you can see there is something called as an optimize operation. I optimized something. So the delta or the log file contains every transaction that is happening within the corresponding data. Because of this concept of delta Parquet, that is Parquet is best for quick data retrieval and best compression aspect. The data is being preserved in the Parquet format. The delta is to have each and every transaction that is happening is being preserved. Now it is this combination that is used in something called as delta lake architecture. You might have heard a terminology called delta lake architecture in the data world. So it is this aspect that helps multiple features and functionalities like time travel. And we would cover in detail when we go across. But in layman terminology, if I have to explain the benefit of this, imagine that if I only had Parquet file, correct? I don't know at what time what data was present. So if I want to go and check what was the data in this table as of last day, correct? There is no way for me to go back. But since the data is being preserved in the form of delta Parquet, and at every aspect there is a transaction involved with the corresponding timestamp, correct? The corresponding timestamp. So because of that, in case if I want to identify what was the state of this table during some X time, I can time travel. I can scan what happens. It scans across the JSON files, goes across that corresponding data transaction table, and then goes back and identify the corresponding data table and provides me the data as of that instance. Rather than I explicitly having to preserve the snapshots, this delta Parquet file format itself takes care of that. This is what we call as time travel. This is just for theoretical aspect. We would actually take practical demonstrations and look once we actually come into that case scenario of Lakehouse and Fabric Warehouse. But just for you all to understand why Microsoft is having its base underlying data preserved in the form of delta Parquet. Since Fabric is an analytical platform, and for historical analysis, we do have to go back in time. What was the revenue as of that day? One way is I can daily create a snapshot of the revenue, or I can have the latest transaction available in the data, but via the time travel functionality, I can go back to the data of that corresponding duration. This is what we call as time travel. And the time travel is possible because of this concept of delta Parquet. Any queries?
So Nandan, every transaction, right? It's create a new delta log
JSON.
file, correct? Right?
Perfect.
That is the biggest difference between the SQL and the Parquet file.
Correct. Yes, Siddesh.
As you're saying, it's a transaction. So, like, if it is having a PI data, and architects consider like to have it a mask or unmasked. So, if it masked after 7 days, like previously it is loading as unmasked, but after 7 days, they're considering it to be unmasked, sorry, masked. So, in that scenario, can we do the time travel and see the previous data when it was unmasked?
Okay. So let me reiterate the question that was asked. In today's world, there are certain rules and regulations called GDPR, Global Data Protection Regulation. And in terms of health sector, it is HIPAA policies that follows. Correct. So now let's say that I am part of an organization wherein I added my data. Correct. Then after a span of, let's say, 5 years, my data is present across multiple transactional or multiple Parquet files. Now imagine that I leave the organization and via the GDPR rule, I state that the organization should scrub all my PII data, meaning nowhere should my personal data, any data, my name, my mobile number, my email ID be present within the organizational systems. Correct. So in that case, I can go and delete the latest transactional data. But because of the time travel aspect, I can still go back in time and check the data, which is against the rule and policy. So the question was, will the user be able to go back in time and go check across the data? The answer to that is yes. The user or the analyst would be able to go back in the data because the latest masking or the latest deletion that I did was at the latest transactional aspect. But there are historical values. Correct. So via time travel, I can go back in time and identify those data. But then the question comes, then is that a secure way? There are other concepts within this delta aspect. So up till now, we discussed time travel to go back in time. But there are ways to ensure that even historical data is deleted. That is, you delete data beyond some time, meaning you cannot go beyond this time in time travel. That is what we call as vacuum. I am vacuuming the historical parquet and the transaction, the log files. Since the files, the transactional files are no longer and the actual data files are no longer present, I cannot time travel back. These concepts are advanced concepts that would actually take a physical, practical demonstration of the same as and when we cover the basic concepts of what Microsoft Fabric is. But since you all asked the question, I provided a basic understanding of what happens, but we'll actually take a practical demonstration in future scenarios. Any other queries? Now,
Just one
ahead.
small query that with so much transactional detail being captured, will the size not become very big every time you're opening?
It's a Parquet file. Parquet is a column-based file, so it's already very compressed. So
Okay.
these mean a single Excel file with 100 GB would be preserved as menial 10 GB. So 10 different such files, correct, won't bother.
Okay.
Hence, it's the Parquet file format that we, in big data world, it's usually preferred to use Parquet file format.
Okay.
Any other queries? Okay. If no, then I'll cover some of the data world terminologies. And from next session, we would be actually starting on Microsoft Fabric. But before that, we need to understand some data terminologies. First is data base. Now, you would hear a terminology called database. Now, database can be classified into two types: SQL database and NoSQL database, or not only SQL database. So, if you all remember, there were three types of data categorization: structured data, semi-structured data, and unstructured data. Now, in order for me to preserve structured data, there are structured databases available. Meaning, you can preserve the data within those storage layers in the form of rows and columns only. That is what we call a structured database. Now, in order to query the data from the structured database, we have something called as SQL, called structured query language. Then comes NoSQL database. It is not only SQL database. Now, what do you mean by not only SQL database? It means those databases can preserve structured data and semi-structured data. So you can execute the queries not only via SQL, but via other aspects as well to query the structured and the semi-structured data. Hence, it's not only SQL. There are other ways as well to query the data. Now, within databases, there are two classifications. One is OLTP and another is OLAP that we covered earlier. OLTP is online transactional protocol. OLAP is online analytical protocol. Transactional meaning those databases preserve your latest set of transactions. And OLAP is analytical system that contains all your historical data for better analysis. Now, why do you need transactional and analytical databases? The best example is, let's take the case of Amazon again. Imagine that I added 3 objects in my cart. So these 3 are my latest transaction, correct? Imagine that I closed the app and I opened it again. Should my objects be in the cart available? It should be, correct? But every time I open an app, it goes and hits the backend system database. Now imagine that in the backend database, if I have all my historical data, when I say all the historical data, meaning all the previous items that I added in the transactions, sorry, all the previous objects that I had added in the cart and I had bought it, meaning that moved out of the cart. And I add the latest one. Imagine if all the data is present in a single table as item and its state, whether bought or in cart. And now imagine that if I open the app again, it has to query select all from that table where object equal to in cart. So imagine out of 1 lakh rows, I have to only pull in 3 rows. So I have to scan every 1 lakh rows and pull 3 rows. Is that performance efficient? No, correct. 1 lakh is just an example. Imagine there would be millions of such transactions that might have happened. So it's not a good use of having such system, because for the users in UI system, quicker the output, better would be the user experience. Hence, in such cases, it is better to have a system called transactional system that contains only the transactional data, not the previous or the historical transaction. So imagine that in case if I would have had a table or a system that contains only the items that have been added in the cart, but not the previous ones that have been bought. Then of the 3 rows, I would have only had to pick 3 rows only, a quicker retrieval of the data. This is the case of transactional data. But imagine that I want a data like total how much revenue was generated in last 24 hours. At that time, is there a need for me to scan across every rows? No, correct? I can directly go across 2 columns, date and the amount column, and do a aggregation. So those are what we call as OLAP systems, wherein you preserve the historical data and those are better for aggregations. Now, this is one way of categorizing the databases. Now for this set of categorization, where I said there are certain terminologies in the traditional day in, day out. Now let's come to another set of categorization. Now, as I said, there are three types of data: structured, semi-structured, and unstructured data. Now imagine that I said, correct, databases preserve only structured data or semi-structured data, not unstructured data. So in data world, the database that preserves all your historical data is logically termed as data warehouse. It's a warehouse of your data. These are not the terminology only used in Microsoft or Microsoft Fabric per se. It's in general in the data world. Any database that contains all the historical data in one centralized location is what we call as data warehouse. Now, as an organization, correct, I am a startup. I would have some financial data, like for the bootcamp, you all paid me certain amount. Also, I had to buy some licenses for the demo. So there was revenue come expenses. So that is my financial data. Then there would be HR data, wherein there are some employees within my organization, or there are customers, correct, like you all who are part of this bootcamp. So those are different domains, data domains that we had seen in the Fabric workspace, correct? So imagine that if I want to do analysis only for financial data. So rather than querying the warehouse entire, which contains the centralized data, which contains all the data, I can have a database specific to that corresponding domain itself. That is, I can have a database that contains only the financial data or contains only the HR data. That database is called data marts. Data marts are basically a subset of data from the data warehouse. So data warehouse is the superset that contains all the data, whereas data mart are subset of the warehouse that contains data specific to that corresponding categorization of or domain of data. But up till now, both of the systems that we discussed supports only structured or semi-structured data. But what about unstructured data? In today's world, wherein unstructured data is at the peak, like let's say that while traveling, if you have exceeded your limit while driving, then there are speed detectors. There are IoT sensors that detect you have exceeded the threshold, and via the video or image capture, it would capture your license plate. Then I have to scan that now that license plate that was captured or the video that was captured. These are unstructured data. These are images or video files. Now I have to preserve that as a proof somewhere, correct? And then process that data. So then with this evolution of managing and processing unstructured data, the traditional databases and data warehouse didn't suffice these requirements. Hence came the concept of data lake. Data lake is basically a system that is a storage layer that supports loading of structured, semi-structured, and unstructured data. So with the evolution of data requirements and majorly unstructured data came the concept of data lake. So data lake helps in preserving of structured, semi-structured, and unstructured data. So considering these three terminologies, let's compare the equivalent of these terminologies in the Fabric ecosystem. When I said the data lake equivalent in Microsoft Fabric is the Lakehouse component. And in the Azure ecosystem, those who have worked on Azure ecosystem, or you all have worked, we had created Azure Azure storage account, correct? So Azure storage account is the data lake equivalent. Data Lake Gen 2 is the data lake equivalent in Azure PaaS. Lakehouse is the data lake equivalent in the Microsoft Fabric ecosystem. Then Fabric Warehouse is equivalent to the data warehouse in the Fabric ecosystem and is equivalent to Synapse Serverless. Those who have worked, those who have some experience in Azure Synapse Analytics. If you do not have any experience in Azure Synapse Analytics, you can ignore this terminology. But for those who have some experience, this is a one-on-one comparison. So the Fabric Warehouse is the data warehouse equivalent in the Microsoft Fabric ecosystem, which is equivalent to the Synapse Serverless in the Synapse Analytics workspace. The SQL database is the and the Fabric Warehouse is basically an OLAP system for analytical purposes since it contains historical data. The SQL database is equivalent to the data mart aspect or the transactional database, and it is equivalent to the Azure SQL database in the Azure PaaS ecosystem. The KQL database is a NoSQL database that we will discuss in detail. Let's not deep dive into that. So these are the basic understanding of the data world. Any queries?
Andra, what is the full form of KQL database?
KQL stands for Kusto Query Language.
Kusto query. Okay.
We'll discuss in detail in the subsequent sessions.
For Fabric, how much SQL and how much Python we need?
It's not specific to Fabric, it's data world, correct? In data world, it is necessary in any data tool, it's necessary to know SQL. Python is good to have for some advanced set of transformations that you would see subsequently. But in Fabric, the minimum requirement is to know SQL. Python is a good to have feature or functionality.
Nandan, what do you mean by proprietary storage format?
Sorry, what do I mean by?
Proprietary storage format.
Sorry, I'm
Proprietary storage format.
Yeah,
He's
let me
asking.
proprietary storage format. It means we do not know what the underlying Microsoft, meaning we do not know what the how the data is stored in the backend, meaning in the backend, because the underlying service provider has not disclosed that. Meaning Microsoft has not disclosed how it preserves the data in the backend, in the KQL database or the SQL database. So it's the corresponding service provider's own way of preserving that data. Clear?
Yeah, and then I have question.
Go ahead.
So lake house, okay, is it like lake house store the physical data, or one lake store the physical data?
You are going into Microsoft Fabric. Did I discuss one lake today, Ramesh?
No. So yeah, lake house. So lake house store the physical data, or
Yes,
behind the scene?
Lakehouse does store the physical data. Lakehouse is like your storage data lake.
Data lake. So behind the scene, data will be stored in the data lake, right?
Data lake is a logical terminology. It's the lakehouse that is the actual component. Corresponding to every cloud service provider, it has its own version of data lake. In Microsoft Fabric, Lakehouse, this is the data lake. In Azure PaaS, Azure storage account that we had created was the data lake. So data lake is a logical terminology of the component. It's the lake house. That's the physical aspect.
Okay, so can we say like it is built on Delta Lake, a data lake house built?
Sorry?
Can we say like lake house is built on top of data lake?
Data lake is a logical concept. It is not a physical aspect. Lake house is built on the lake house. Lake house is the actual concept. You are trying to mix your partial knowledge on one lake with this. Do not mix those aspects.
Okay.
In the subsequent session, I'll come to the concept of one lake. I'm understanding in which direction you are going. Correct? Let's hold on to these questions when I actually come to those topics. Correct? Do
Okay.
not
Yeah.
mix it because it would be confusing for you as well as for the other folks as well. Clear?
Okay. Okay.
Just understand, are there any queries in whatever we discussed as of today?
Yeah. Okay.
One lake is a logical concept. It's just a logical way. It's not a physical aspect. Lake house is the physical aspect.
Yeah, that's what I understand.
But remember, Ramesh, here there are other folks as well, correct? For them, they do not know what one lake is. If you bring those aspects, that would lead to a confusion for others. So once we actually
Yeah,
go into
sorry
those
for that.
topics, let's clear those aspects. Clear?
Yeah, clear.
Any other queries, Steve? Okay, if no queries, then since one lake or the Microsoft Fabric is a separate 1.5 hour session, we'll start that from Monday onwards.